Hi guys, welcome back to this channel. For today's video, we'll discuss about physical properties of your alcohol. So in alcohol, we have two physical properties that we'll discuss, but in this part 1 video, we will focus only on boiling point. In boiling point, we have two conditions that we'll talk about. The first one is comparing within alcohol. So, what is meant by comparing within alcohol is you can compare your methanol and also propanol. And we will see which one have higher boiling point. Or you can compare your pentanol with cyclopentanol. And we will see which one have higher boiling point and also why that one have higher boiling point. We will also look at the factor affecting the boiling point. The second condition is we can compare the alcohol with alkane. What is meant by compare alcohol with alkane? For example, you can compare your propanol and also butane. And we will see propanol having higher boiling point or butane having higher boiling point. And of course, guys, why they have higher boiling point. Alright? Let's jump straight into the first condition, which is you are going to compare within alcohol. So we have three factors affecting the boiling point within alcohols. The first one is the number of OH group. The higher the number of OH group, the higher the boiling point. Remember that. We'll look into the complete explanation later on in the examples. Alright? The summary of it is the first factor that will be affecting the boiling point is the number of OH group. The higher the OH group, the higher the boiling point. The second factor over here is molecular mass or number of carbon atom. Same thing. The higher the molar mass or the higher the number of carbon atom, the higher the boiling point. Last but not least, molecular shape. And in molecular shape, we are actually going to discuss contact surface area. And the higher the contact surface area, the higher the boiling point. Like I say, we'll discuss about the complete explanation later on when we come across examples. Just want to remind you over here, they are in the flow of 1, 2, 3. In the other words, the first thing that you can check the number of OH group first. The higher the OH group, the higher the boiling point. If the number of OH group are the same, then only we move to number of carbon. If your number of OH group is the same, then only we look at the molecular mass or the number of carbon. Alright? Last but not least, if the number of carbon or the molecular mass is the same, then only we look at the molecular shape. Then only we compare the contact surface area, whether they are in the form of cyclic, straight chain, or branches. So bear that in mind, you can move from the first factor to the second factor is because the first factor cannot differentiate them. You can move from the second factor to the third factor because the second factor cannot differentiate them. They are the same. So that is the factor affecting the boiling point and the flow on how to check the factors. Okay? Let's jump into the first example. So in alcohol A, we have only one OH group. While in the alcohol B, you have two OH group. Can you see that? And we know that this is the example that you have when you have different number of OH group. And we know that the higher the OH group, the higher the boiling point. So the question over here is, why the higher the OH group, the higher the boiling point? Simple. Because OH group are the group that will form hydrogen bond. And we know that hydrogen bond is very strong. So imagine, guys, you have one OH group over here. You have two OH group over here. Which one can form more hydrogen bond? Of course, the two OH group can form more hydrogen bond. So when you can form more hydrogen bond, the intermolecular forces become stronger, a lot stronger. And therefore, you need more energy to overcome the strong hydrogen bond. When you need more energy, automatically the boiling point over here will be higher because you have more OH group. Okay? Let's look at the complete sentence for the explanation just now. So this is my alcohol A with 1 OH group. This is my alcohol B with 2 OH group. The first thing that you should mention is your alcohol B has more OH group than your alcohol A. Second thing is the hydrogen bond. Bear in mind, we cannot count how many hydrogen bond that we have because hydrogen bond is a type of intermolecular forces. It's a type of attractive forces. So we cannot calculate how many forces we have. Therefore, you can only use the word more hydrogen bond. Bear that in mind, alcohol B, the one that having 2 OH group right now, can form more hydrogen bond with itself than the alcohol A. Therefore, more energy needed to overcome the strong hydrogen bond in alcohol B than alcohol A, because right now alcohol B is the one that having 2 OH group. When you already need more energy, straight away, your alcohol B will have a higher boiling point than alcohol A. Simple, straightforward and simple. The more the OH group, the higher the boiling point because more hydrogen bond. Easy. As a conclusion, the higher the number of OH group, the higher the boiling point. Remember this. Okay? Next example is you have your alcohol C over here and your alcohol D over here. But what makes it different from the previous example is you can see over here the number of OH group is the same. So when you have the same number of OH group, guys, can you use the first factor? You cannot use the first factor because they are the same. You cannot differentiate which one have higher OH group. Therefore, you move to the second factor, which is a different molecular mass. Look at it. The alcohol C over here having how many carbon? The alcohol C over here having 5 carbon. The alcohol D over here having only 3 carbon. And we know that the higher the molecular mass, the higher the boiling point. And which one do you think have higher boiling point? Obviously, the alcohol C will have higher boiling point because you have more carbon atom. The question over here back to why the higher the molecular mass, the higher the boiling point. So, can we still discuss about hydrogen bond? No, we cannot discuss about hydrogen bond because your hydrogen bond at this moment should be similar. Why should be similar or even the same? Because you only have 1 OH group, 1 OH group. The number of OH group is the same. So, the hydrogen bond between alcohol C and alcohol D should be similar. So, when you cannot discuss about hydrogen bond, what else do we discuss? Van der Waals forces. Alright? So, Van der Waals forces is the one that we are going to look into. And we know that Van der Waals forces is stronger when the molar mass is higher. So, the higher the molar mass, the stronger the Van der Waals forces. The stronger the Van der Waals forces, more energy is needed in your alcohol C. When more energy is needed in your alcohol C to break the strong Van der Waals forces, straight away, boiling point higher. So, bear that in mind, when the number of OH group is the same, hydrogen bond also is the same. Therefore, you cannot discuss hydrogen bond. You cannot discuss about OH group. Okay? We will discuss only about the molecular mass and also the Van der Waals forces. Okay? Remember that. So, the complete explanation for my alcohol C and D that have the same OH group shall always start with what is the same thing. So, you have your alcohol C and D has the same OH group. So that you know, you remind yourself that you cannot discuss about hydrogen bond since the OH group is the same. Therefore, we move on to your alcohol C has higher molecular mass than your alcohol D over here. Okay? So, your alcohol C has a higher molecular mass than your alcohol D over here. Because the number of carbon is higher over here, you have 5 carbon, you have 3 carbon. It's not needed to calculate the molecular mass, By looking at the number of carbon, you can determine which one have a higher molecular mass. Next, therefore, alcohol C can form stronger van der Waals forces than alcohol D because the molar mass is higher. As a result, you need more energy to overcome the strong van der Waals forces in alcohol C, and boiling point of alcohol C will be higher than your alcohol D. And this is the example where we will focus on your molecular mass when the number of OH group is the same. Okay, simple, easy. So remember, the higher the molecular mass, the higher the boiling point. Do not need to calculate the molecular mass, just simply look at the number of carbon atom. The higher the number of carbon atom, the higher the molecular mass. Okay, and the higher the molecular mass, the higher the boiling point, because we have discussed about van der Waals forces between them. Alright, no longer about hydrogen bond. Simple. All the examples above have the same number of OH group. You can see the first compound having one OH, and one OH. But they definitely have a different molecular mass. Do we need to count the molecular mass? No, we can just simply counting the carbon. You can see over here, I have 6 carbon for the first structure. For the second structure, I have 4 carbon. For the last structure, I have a lot of carbon. I have 11 carbon. So 6 carbon, 4 carbon, 11 carbon. Which one have the highest boiling point? This one will definitely be your number 1, where you will have the highest boiling point because it has the highest molecular mass. Followed by, this will be the number 2 because you have 6 carbon. Last but not least, this will have the lowest boiling point because the molecular mass is the lowest. See that? So what I'm trying to show you over here is it's not needed to calculate the molecular mass. You can simply look at the number of carbon atom. From the number of carbon atom, you can determine which one have higher molecular mass. Easy, simple. Next, let's look at the other example that I have on the screen is your alcohol E, alcohol F, alcohol G. And what makes them similar over here? First thing, you have same number of OH group. So when you have the same number of OH group, you cannot discuss about hydrogen bond. Alright? Next, they have a similar or same molecular mass. It's not the same guy, it's only similar molecular mass. They have a similar molecular mass because this is your 5 carbon. This is also 5 carbon. This is also 5 carbon. So when you have a similar molecular mass, you cannot simply mention only about van der Waals forces. Even though in here, we will still discuss about van der Waals forces, but it's not affected by your molecular mass. It's actually affected by the molecular shape. And you should know that your cyclic having a larger contact surface area than your straight chain. And your straight chain will have a larger contact surface area than your branches structure. So in the molecular shape, we will all discuss about contact surface area. Remember this. So over here you can see your alcohol E is a cyclic. Your alcohol F is a straight chain. Your alcohol G having having 2 branches. If that is your straight chain, you have 2 branches. And we know that the higher the contact surface area, you will have more area for the intermolecular forces, which is your van der Waals over here. So the larger the contact surface area, the stronger the van der Waals forces. And as a result, you can definitely know that your cyclic over here will having higher boiling point. Alright, let's jump into the complete explanation for this question. So when you have 3 alcohol over here, and all the 3 alcohol having the same OH group and similar molecular mass. Alright? But the molecular shape is different because your alcohol E is in cyclic. that will have larger contact surface area than the straight chain in alcohol F, followed by the branches structure in the alcohol G. So when you have a larger contact surface area, what happens? You will come across a stronger van der Waals forces due to the large contact surface area. As a result, you will need more energy to overcome the stronger van der Waals forces in alcohol E. Straight away, you will be then knowing alcohol E has a higher boiling point than alcohol F and G. So we have three factors over here, and in these examples, we will discuss the last factor because the number of OH group now is the same. The molecular mass also very similar. So we cannot use the number of OH group and the molecular mass to differentiate them. Straight away, we will jump into larger contact surface area. We will discuss about contact surface area that you have in a different shape in your cyclic, in your straight chain, and in your branches compound. Simple? Easy. As a conclusion, the larger the contact surface area, the higher the boiling point. And the contact surface area will be moving from cyclic to your straight chain. And last but not least, the one that having smallest contact surface area is your branches. So remember, cyclic will have the largest contact surface area, followed by your straight chain, followed by your branches. And bear that in mind, we can only discuss about the contact surface area in your molecular shape is when the number of OH group must be the same and the molecular mass must be similar. Typo over here. Alright, so the molecular mass must be similar and the OH group must be the same, then only we can discuss about the contact surface area. Alright, simple. So remember the three factors over there, okay? So next, we are going to compare our alcohol with alkanes. So we are going to look at alcohol having higher boiling point or alkanes having higher boiling point. What are the factors affecting? The factor affecting is definitely the strength of intermolecular forces, and we have two intermolecular forces. We have hydrogen bond and also we have van der Waals forces. So the question over here, alkane having hydrogen bond or van der Waals forces? And between hydrogen bond and van der Waals forces, which one is stronger? We'll look at that in the explanation later on. I just want to remind you over here, when you are comparing your alcohol and also your alkanes, all your alcohol and alkanes must have a similar molecular mass. Then only we can compare them. Alright? If you want to compare your alcohol and alkanes, they must have a similar molecular mass. The most important thing in the strength of intermolecular forces is knowing that your hydrogen bond is a lot stronger than your van der Waals forces. This is the keyword that you must always have when you're comparing hydrogen bond and also van der Waals forces. One mark for this, hydrogen bond is stronger than van der Waals forces. Make sure you have this down. So the question next will be, alkane having hydrogen bond or van der Waals forces? We know that your alkane having only weak van der Waals forces, while in your alcohol having hydrogen bond. And we know that which one is stronger? Hydrogen bond is stronger. When hydrogen bond is stronger, alcohol is having higher boiling point or alkane having higher boiling point? Straight away, definitely alcohol higher boiling point. Alkane lower boiling point because hydrogen bond is stronger. When hydrogen bond is stronger, you will need more energy to overcome the strong hydrogen bond. Straight away, boiling point higher in alcohol. Back to the same condition, the alkane and alcohol must have a similar molecular mass. Alright, the molar mass over here must be very similar between the alcohol and alkane. Alright, let's look at our example. I have my alkane 4 carbon over here. I have my alcohol 3 carbon over here. And if you work out the molar mass of this alkane is 58 gram per mole, while for this alcohol is 60 gram per mole. So by looking at the molecular mass, you know that their molecular mass are similar. And obviously, due to the presence of OH in the alcohol, in this alcohol, you will have the presence of your hydrogen bond. And in your alkane, there is only carbon-hydrogen. Therefore, you only have your weak van der Waals forces. And we know that your hydrogen bond is a lot stronger than your weak van der Waals forces. When your hydrogen bond is stronger over here, you will need more energy. And straight away, when you need more energy to overcome the strong hydrogen bond, the boiling point in your alcohol must be higher than your alkane if their molecular mass are similar. Okay, let's look at the full explanation for this. First, we are comparing butane and propanol over here. So, they have the similar molecular mass between both compounds. We have talked about that just now, 58 gram per mole. And over here, you have 60 gram per mole. So, similar molecular mass. Then, mention about their type of intermolecular forces. Butane having only weak van der Waals forces. Propanol having strong hydrogen bond. Keyword, hydrogen bond in propanol is stronger than weak van der Waals forces in propane. Okay, hydrogen bond is stronger than van der Waals forces is a must over here. As a result, you need more energy to overcome the strong hydrogen bond in the propanol, and the boiling point in propanol will be higher than propane. Simple, easy. So when you're comparing your alkane and your propanol, alright, your alcohol, we will definitely talk about type of intermolecular forces. Butane having only weak van der Waals forces, your alcohol having strong hydrogen bond. Okay? Simple. And to be honest, that's it for this video. Conclusion for the boiling point when we are comparing within alcohol. When you're comparing alcohol and alcohol, we have three factors. The first factor is we look at the number of OH group. The higher the OH group, the higher the boiling point. And then if the OH group is the same, then only we can talk about the second factor, which is your molecular mass or the number of carbon. The higher the number of carbon, the higher the molecular mass. Therefore, the higher the boiling point. Okay? And if the molecular mass or the number of carbon are similar, then only we can talk about the molecular shape. And in the molecular shape, we will discuss what? We will discuss about contact surface area. Contact surface area means we are going to look at whether they are cyclic, that having larger contact surface area than the straight chain, than the branches. So bear that in mind. Molecular shape is the last one that we will check if the number of OH group is the same, if the number of carbon is the same. Alright? Simple. Next, let's look at the boiling point that when we compare alcohol with alkanes. Alright? And the factor that we'll talk about, definitely the strength of intermolecular forces. Knowing that your alcohol can have hydrogen bond and your alkanes can only have weak van der Waals forces. And the most important thing is, we know that hydrogen bond in the alcohol is stronger than the weak van der Waals forces in your alkanes. Therefore, which one have higher boiling point? Your alcohol will have a higher boiling point than your alkane. Alright? Bear that in mind, we can compare the alcohol and the alkane that have a similar molecular mass only. Alright? Simple. And that is all about the boiling point that we want to discuss in this video. If the video able to help you, don't forget to smack the like button and subscribe to my channel. Thank you for watching, and I shall see you in the next video.